Hello, everybody, and welcome to our class on introducing Git and GitHub. When you hear the term Git, you might think immediately of GitHub, but they're different. Git is actually a language, and GitHub is a way of organizing that on the web, of using Git commands on the web. And so this is just a brief introduction of the very basics. There's many more tutorials on this. And we'll be using it so often in class that it'll become second nature, but this is just an intro to preview of some of the things we'll be using over and over again when we actually go over the markdown file of installing Git or connecting to GitHub. So the goals are just to give you the basic core concepts of Git, why use remote repositories like GitHub, and some of the basic commands that you'll use. And again, we'll go over those in the next video when we go over the markdown file of cloning our GitHub for the class and other aspects. So it's just this is just a little introduction that Git is a programming language. And it was created by Linus Torvalds, who also made Linux that we're basically using. What's amazing is that he made it in 4 days. But really what it did is allowed documents to be tracked in time to see what had changed. So essentially, if you've ever used Word where you diff documents, Git has the ability of taking a snapshot of a file and making sure its integrity is correct. And then when the next Git command or push to that happens, it'll record the next file, but you can immediately see what the difference is between those and also between many different versions of it. So it's sort of like doing Google Documents on tracking, but you're seeing what was changed every time something was recommitted to the Git repository. So the basic principles of Git is that it's going to store snapshots of your project over time. You don't have to use GitHub. You can use Git just on your terminal and do simple commands, and this same process will happen. Where you first start out your project, and you have file A, B, and C, and then now you change file A and file C, so you have A1 and C1, and then you change file C, so now file C2 is changed, and you can see on and on. Along this chain, Git is going to remember what files have changed, which have been removed, which has been added, and et cetera, et cetera. And it also has checksum integrity to make sure that the snapshot taken is exactly what it's referring to, sort of like we did with MD5 sums earlier. And in Git, you don't want to store big files like images or output files or PDFs. And we'll, in the next video, make a Git ignore of files we don't want to have tracked. Some of these files might be too big, like file B, let's say, was a FASTQ file. We certainly don't want that going into our Git tracking system, if you will. And GitHub will limit you to a very small amount of storage so that you make sure to only upload very light files. Like don't add binary files. That's a very bad thing. And so this is really what you're doing is you're working in your home directory. And when you do something, you want to stage it to get to Git. So it's staged to say, hey, I'm tracking this file. I see all these changes, but I'm not going to commit them until you're ready. And then when you do commit, then you go to the Git repository or directory. And GitHub is just a web version of looking at that directory. This again will make sense the more and more we do it, but basically you're pushing towards the Git repository, and then if your collaborator did something, you'd want to pull the current version of that project back into your working directory. And the staging area is really just for each individual user as they're fixing their file. So when you commit, you're committing the file saying, hey, I'm done with the file for today. This is where it's at. It has a key to make sure the snapshot's correct. And then the next snapshot, snapshot B, can easily compare with snapshot A, so on and so forth. So you can really see how things have changed. And you'll see that when you commit, you can have a little message here that says the initial commit of my project, fix the bug. You just kind of have a markdown of what you've been doing along the way. So your collaborators know what you've changed. And then they can actually see the code you've actually directly changed in comparison. So Git has branches. The master branch is sort of where you want to put all your final product code. You don't really want to work with collaborations on master. There should be one sort of person who's managing the project that's in charge of the Git directory or Git repository, and they're on the master branch, and you might be a collaborator, let's say, on a testing branch. And so you're going to clone all of this stuff. You're going to change a file. It's going to have a code to know exactly what you changed, and it's going to come into this zone where it could be merged back into master. So it could change by another collaborator down the road, but eventually you might want to say, okay, this file is good to go, and then you would send a pull request to the master branch to merge, merge request to merge this branch in there. So in class, you guys will be working on the students branch in our Git repository, fixing all the same documents we're working on, and then we'll merge them into master once we've completed them. And so it's nice because Git will remember everything you've done and what has been done on what branches. This is just an example of it to show you here from when you look at a tree in Git as a command. We'll give you a little cheat sheet command at the bottom at the end of this lecture. And this is just showing the trees that I have and the different branches. You'll rarely look at this now in the days of GitHub. You can pretty much just go to the web and figure all this out. But it is not a backup. It's not like it's backing up your data. It's only backing up your code. And that's probably the most important thing, because you can just rerun the fast queues and then rerun the code. And so you'll always have that text tracked. So this is just an image of kind of what we've been discussing. Everything's still happening on your computer. It's just what repository you're using Git commands to sync to. So this is GitHub here, where you can have several people working from their own computers and maybe on different branches working across that. And then this can all be merged into GitHub, where you can all see your collaborative work populating here. But everything is on your computer, and you're just pushing data, your code, to this repository, and the master branch will decide whether it wants to merge that in or not as you go. So having said all that, really the thing with Git is you just have to use it and use it and use it and use it every day. And at the end of the day, do a Git commit, Git push, and leave for the day. But this is just a graphic saying, yeah, it's a bunch of stuff. Basically, I just do the same thing. And really all you're going to need to know at the end of the day of things you would type in the terminal is git commit with -m for some markdown of what you've just done. That's in that staging section. So we're staging it to go to push it to the branch we're on, and then you can leave the building. So in case of a fire, your code will be safe if you just do git commit -m and write something in quotes, like tell your collaborator there's a fire, push it, leave the building, and the internet will still have your code stored. So here's some basic things we'll do, and in the next video, we'll actually use these commands to clone the class repository in your computer. So all of these pre-cooked documents, everything will just show up on your computer, and then you can change them, and we'll see if we want to merge them. So really, this won't matter so much for now, just in the lecture slides if you want to refer to this. But we're going to use all of these on the terminal, which is technically Git bash, or Git. And GitHub is just a web interface to look at this directory that we're working in together. And so in a way, GitHub is great, but it is not Git. GitHub is not Git. It is a social network of collaboration, and anybody, we found a little bug in a Nextflow script and sent it to their Git repository and modified their documents and maybe you want to change this. And so then they can decide if they want to merge that into their master branch. So you can collaborate with anybody that's on GitHub, and you won't interfere with their master branch because they'll have to decide whether they want to merge that in the changes you're making. Okay, so with that, we will start to learn how to install and clone the class GitHub in the next video. Until then, code light.